Hello students. Now come to the exercise 1.3. The first question is write the following in decimal form and say what kind of decimal expansion each has. The first one is 36 upon 100. So to write in the form of decimal we need to divide 36 by 100. So divide and we have seen the answer has come 0.36 and remainder has come 0. It means which kind of decimal it is? It is terminating because remainder has become 0 here. So in the decimal form we can write 36 upon 100 is equal to 0.36 and it has terminating decimal expansion because decimal has 0 here and it has terminated. Now come to the second one, 2 upon 11. So we need to divide 2 by 11. So as we have seen the remainder has come 9 here. So again the remainder has come 2 and again these are repeating. See 9 then 2 again 9 then 2 and 1 8 is repeating after the decimal. These two digits are repeating. It means it is non terminating. It is it will not come 0 and it is repeating also, means we can write 0.1818 and so on. So here 18 are repeating, so we can put bar over them, means we can put bar on 1 and 8. And which kind of decimal expansion it is? It has non-terminating recurring decimal expansion because it is the remainder is not becoming 0. So decimal is not terminating, it is not finishing, and it is repeating. We can see 1 8 are repeating, so recurring. It has non terminating recurring decimal expansion. Now come to the question number second. You know that 1 upon 7 is equal to 0.142857. Can you predict what the decimal expansion of 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7, 6 upon 7 are without actually doing the long division? If so, how? So we know that it is given that 1 upon 7 is equal to 1.414287 bar. So we can write 2 upon 7 as 2 multiplied by 1 upon 7. Now in place of 7 put the value of 1 upon 7, that in decimal form. So now we multiply 2 with this. So answer is coming 0.285714 bar. This is the value of 2 upon 7. In the same way, we can write 3 upon 7 is equal to 3 multiplied by 1 upon 7. Then after put the value of 1 upon 7 and then after you will multiply. In the same way, you will find for 4 upon 7, 5 upon 7, 6 upon 7. Now come to the question number third. Express the following in the form of P upon Q where P and Q are integers and Q is not equal to 0. The first one is 0.6 bar. It is 0.6 bar. When we need to write a decimal number in the form of P upon Q, firstly we assume that x equal to the given decimal number. We will write in this way, let x equal to 0.6 bar. Now we need to make two equations. In the first equation, decimal should just before the repeating digit. Here which digit is repeating? 6, and decimal is already just before the 6. So this will be our first equation. Now in the we need to make the second equation. In the second equation, the decimal should be just after the repeating digit. Here 6 is repeating. It means here so many 6 are here. We need to move this decimal after 1 6. Here so many 6 are here, so we need to multiply by 10, then it will become move towards right hand side by one place. So we will multiply the equation number first by 10. So multiply by 10. Now 10 into x, 10x equal to 0.6 multiply by 10. How to do the multiplication I have shown here at the side of this. 0 points bar means so many 6 are here, 6 6 6 and so on, then multiply by 10. So when we multiply by 10, so decimal will move towards right side one place. It will become 6.666 in this way. So we can put bar over it, so it will become 6.6 bar. Now come to the next thing. Now we need to subtract the equation number first from equation number second. So 10x. Firstly I have written the second equation, then after below it I have written the first equation. Matlab I have done this in column wise. Now 10x minus x will be 9x. 6 minus 6.6 bar minus 0.6 bar, so answer will be 6. So x equal to 6 upon 9, means if we divide them, so it will become 2 upon 3. Now this is our required p upon q form. Now come to the second one, 0.47 bar, means bar is on the 7 only, means only 7 is repeating. So firstly we will assume that x equal to 0.47 bar. Now we need to make the first equation. In the first equation the decimal should just before the repeating digit, but here it is not. So we need to move decimal before 7 which is repeating, so we need to multiply by 10. So we no, now we are going to multiply by 10. So it will be 10x multiplied by 10 will be 10x, and here I have done the multiplication, so decimal has moved here, so it will become 4.7 bar. So this is our equation number first. Now we need to make second equation. In the second equation decimal should just after the repeating digit. Which digit is repeating here? 7. Means we need to move decimal after 1 7. There are so many 7. So I have shown here how to multiply. The number is 4.7 bar and we are multiplying by 10. 4.7 bar. Why we are multiplying by 10? Because we need to move the decimal after 1 7. So many 7s are here, so after 1 7. So multiply equation number first by 10. So 10 multiplied by 10x equal to 100x. 10 multiplied 10x will be 100x equal to 4.7 bar multiplied by 10. I have shown here how to multiply by 10. 4.7 bar. Bar means so many 7 are here. Multiply by 10, so one decimal will move towards one place, towards right side one place. So it will be 47.777. So 47.7 bar here. So I have written here 47.7 bar. This is equation number second. Now subtract the equation number first from equation number second. So 100x minus 10x equal to 47.7 bar minus 4.7 bar. We can write in this way also, or in the column wise also we can do the subtraction. Now 100x minus 10x equal to 90x. 47.7 bar, I have shown here how to do the subtraction. 47.7 bar minus 4.7 bar. Decimal should be below the decimal and do the subtraction, and answer is coming 43.0 means 43. So I have written here 43. So x equal to 43 upon 90. This is our this is our required answer, p upon q form. Now question number 4 you will do by yourself. It is as question number 3. Now question number 5. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 upon 17? Performing the division to check your answer. In this way, by long division method, you will do the division. 1 by 17, 1 will be the dividend, 17 will be the divisor, and you will put decimal, and 1 0 will come here, 10 will be again smaller than 17, so we will put 0 here. Now it is 100. So 17 5 time 85, remainder will be 150. Then again then after you will take 8 time. So in this way we will do again and again, and you will until you get the remainder again same, it has repeated. See, one remainder has come here, again it has come 1 as it was in the beginning, and see the digits, so many digits are here which are not repeating. Then after it will start repeating, because here one remainder is left. Then after we will put 0, we can put 0 because there is decimal, but we 0 is 10 will be smaller, so again we will put 0 here as we did in the beginning, so it will become 100. So again we will take 5 time 85, so remainder will be again 15. Then we put 0, it will become 150, so again we will take 8 time, so it will start repeating from here. So we need to see how many digits are there in the decimal expansion of 1 upon 17. Now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 digits in the block of they are asking how many what can the maximum number of digits. So maximum number of digits there are how many? 16. So 16 digits are there in the repeating block of the digits in the decimal expansion of 1 upon 17. You will write in the form of language also at the end from the question. Now come to the question number 16. Look at several examples of rational numbers of rational numbers in the form of p upon q, where q is not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representation. Can you guess what property q must satisfy? They are saying in some rational numbers which are in the form of p upon q. P upon q, all rational numbers are in the form of p upon q. So for example 1 upon 2 or 7 upon 8. So 7 and 8 both are p and both p and q are integers and q is not equal to 0, and they are having their common factor 1. 1 up in 1 upon 2 also common factor 1, and they also have both having terminating decimal expansion. So q can you they are asking, can you guess what property q must satisfy? So we'll write, we know that only rational numbers can be written in the form of p upon q, where p and q are integers and q is not equal to 0. In some cases p and q are integers with no common factors other than 1 and having terminating decimal expansion. In this case q must satisfy a property that prime factorization of q has only power of 2 or power of 5 or both. Q must be in the form of 2 to the power 2 raised to the power m and 5 raised to the power n, where the value of m and n can be 0, 1, 2, 3 and so on. Now see some examples of rational numbers. Here see the prime factorization of q. Q means denominator. You can see it has the power of 2. Okay, 2 to the power 3, and in the second one again it is in the form of power of 2. In the third one it is in the power of 2 and 3 or 2 and 5 both. So these are the rational numbers with no common factor. Here 7 and 8, they are having no common factor other than 1. Here also, in the same way here also. So these are also having terminating decimal representation. So q must follow this property that the prime factorization of 2 must have power of 2 or power of 5 or power of 2 and 5 both. Now question number 8, find the different irrational numbers between the rational number 5 upon 7 and 9 upon 11. Firstly we write the decimal form of 5 upon 7. It is 0.714285 bar, and 9 upon 11 it is 0.81. So we have firstly assumed that the irrational number between 5 upon 7 and 9 upon 11 are a, b and c. Now after finding the decimal form of 9 upon 11 and 5 upon 7, we will write the numbers between them. See here how. So we can write in this way. In the 5 upon 7 it was 0.71 something, and in the decimal form of 9 upon 11 is 0.81 something. So we can write between them 0.720, 7200, 7200 and so on. Here the decimal expansion is not non-terminating, it is not ending, and it is not also repeating. So you can see 720, then 7200 in this way. And here in the second one I have written 7568120. It is not terminating, non-terminating and non-repeating. And in the third one 0.80100100100001 and so on. And it in all three are non-terminating and non-recurring. The last question is classify the following numbers are rational or irrational. So see the first one under root 23. So it is irrational. And second one is under root 225. So we will write this in the form prime factorization inside it. We will solve and it is coming 15. So 15 is a rational number. Now see, we can see it is the decimal form is given, it is terminated, so it is a rational number. Again you can see in the decimal form it is non terminating but it is repeating, so again it is a rational number. And see the last one decimal form, it is non terminating and non repeating, so it is a irrational number.